Hello friends, I welcome you in lecture number 20 on hypothesis testing. In this lecture we are going to discuss about large sample test on the difference in population proportions. So before going for this question, we recall the necessary formulas related to this question. So here we are going to compare two populations, and for that we assume that we have population proportion for first population is denoted by P1 and P2 is the population proportion for second population. Suppose we are considering a sample of size N1 from population 1 and sample of size N2 from population 2. Suppose X1 is the number of observations with particular class of interest in this sample, and similarly X2 is the number of elements with particular class of interest from this sample. So using this sample data we can find out the sample proportion for that particular class of interest, and here also we will have sample proportion for this second sample. And we want to compare these two population proportions. So suppose we assume that this null hypothesis H0 P1 equal to P2 is true. Then if sampling distribution of sample proportion for each sample is normal and if two samples are independent, then the test statistic for hypothesis test on the difference of proportions is given by capital Z equal to P1 hat minus P2 hat divided by square root of P hat times 1 minus P hat times 1 over first sample size plus 1 over second sample size, and this is approximately a standard normal random variable. If two samples are independent and sampling distribution of sample proportion is normal for both given samples, provided that samples are independent. So keep in mind this information if you want to consider the hypothesis test on the difference of two population proportions. You must be familiar with this formula of test statistic and all these terms. So whenever you have this type of question, you will not be given these values, you will not be given population proportions. So here we are using P hat. So that P hat is the estimator of this common value of population proportion, and that P hat is given by this formula x1 plus x2 divided by n1 plus n2. So in the problem related to this, you will be given sample sizes and you will be given the number of elements with particular characteristic in those two samples, and using this data you have to find out this estimator for this common value of population proportion, and then using these two formulas you will be able to decide sample proportions, and then you will calculate value of test statistic. And we know that this Z follows a normal distribution, so to find out critical values we will use cumulative standard normal probability table. So with this in mind, we try to answer this question which was asked in GTU Summer 2020 exam. If 57 out of 150 patients suffering from certain disease are cured by allopathy and 33 out of 100 patients with the same disease are cured by homeopathy, is there a reason to believe that allopathy is better than homeopathy at 0.05 level of significance? So here we are given two samples, one sample is the sample of patients who are cured by allopathy medicines, and another sample is the sample of patients who are cured by homeopathic treatment or who are cured by homeopathy. And they ask you that is there a reason to believe that allopathy is better than homeopathy. So here we have to consider population proportions, as we will consider P1 equal to proportion of all patients who are cured by allopathy. That will be our first population proportion. We will consider small p2 as proportion of patients cured by homeopathy, and we don't know what is this population proportion and this population proportion, but we are having samples related to these two population proportions. For allopathy, we have a sample of 150 patients, and out of those 150 patients, 57 are cured by allopathy. So here we can consider N1 equal to 150. Just a minute. There are 150 patients in the first sample related to allopathy, and the number of patients who are cured by allopathy are 57 in this sample. Similarly, they are considering a sample of size 100 for homeopathy, and they find that out of these 100 patients, 33 are cured by homeopathy. So using this information, we can find out the sample proportions P1 hat and P2 hat, and we assume that both the samples are independent. There is no relation between the treatments of homeopathy and allopathy, and we also assume that sampling distributions of P1 hat and P2 hat both are normal. Therefore, sampling distribution of P1 hat minus P2 hat will also be normal. So we have this data, and using this data we have to find out value of test statistic, which is P1 hat minus P2 hat divided by square root of small p hat times 1 minus p hat into 1 over n1 plus 1 over n2. What is this small p hat? It is the estimator of common parameter, which is x1 plus x2 divided by n1 plus n2. And here we have to decide that allopathy is better than homeopathy at 0.05 level of significance. So we can say that allopathy is better than homeopathy if the portion of patients cured by allopathy, that is small p1, is bigger than small p2, which is the proportion of patients cured by homeopathy. If this is true, that p1 is greater than p2, then we can say that there is a reason to believe that allopathy is better than homeopathy. So we will consider null hypothesis as equality, that two treatments are same or the fraction of patients cured by homeopathy and allopathy are same, and we will consider this as alternative hypothesis. So I have written all these things systematically here. First I am writing notations for allopathy. I denote the proportion of patients cured by allopathy by small p1, and I call sample 1 as the sample of patients for allopathic treatment. So there are 150 patients in this sample, and the number of patients in this sample cured by allopathy are 57. So I can decide sample proportion for first sample by this formula: p1 hat equal to x1 over n1 x1 is 57, n1 is 150. That is sample proportion for first sample is 0.38. Similarly, we denote proportion of patients cured by homeopathy by small p2, and sample 2 is the data for patients cured by homeopathy. So they are taking 100 patients and they find that the number of patients out of 100 who are cured by homeopathy are 33. Therefore, sample proportion for homeopathic treatment is P2 hat equal to x2 over n2, that is 33 over 100, which is 0.33. So here this is sample proportion for allopathic statement, this is sample proportion for homeopathic treatment, and we can see this is bigger than this one. So this may suggest that allopathy is better than homeopathy, but that is not always true. We have to test the hypothesis on the difference between these two population proportions. P1 is the population proportion for allopathic treatment, small p2 is the population proportion for homeopathic treatment. Before applying our test, we assume that two samples are independent, or we can say that two treatments are independent, and we require these conditions also. N1 P1 times N1 times P1 is greater than 5, N1 times 1 minus P1 is greater than 5. This means sampling distribution of sample proportion for first sample is normal. Similarly, this is also required. N2 P2 is greater than 5, N2 times 1 minus P2 is greater than 5. This means sampling distribution of sample proportion for second sample is also normal. Instead of writing mathematically, we can also write in this way, that sampling distribution of sample proportion is normal for each sample proportion. So these two conditions must be there to apply this hypothesis test for difference of proportions. Now we consider null hypothesis as small p1 equal to small p2. Alternative hypothesis is that p1 is greater than p2, that is proportion of patients cured by allopathy is bigger than the proportion of patients cured by homeopathy. This means allopathy is better than homeopathy, and we assume that null hypothesis is correct and we test that null hypothesis. And because we have this greater than sign here, this is going to be a one-tailed test or upper-tailed test or right-tailed test. Level of significance is given as 0.05. We assume that null hypothesis is true, that is small p1 equal to small p2 equal to some common value which is denoted by small p. So we don't know what is small p1 and small p2. So we have to decide this small p, which is common parameter. So for that we will consider this estimator denoted by p hat. P hat is the estimator of this common parameter denoted by small p, and it is given by x1 plus x2 over n1 plus n2. An estimator of common parameter p is p hat equal to capital X1 plus capital X2 divided by n1 plus n2, and we have all these values. Capital X1 means number of patients cured by allopathy, which is 57, n1 is 150. Capital X2 is number of patients cured by homeopathy, which are 33 out of 100. So we substitute all those values here and we find that this estimator of common parameter is p hat equal to 0.36. So once we have all these values, we can find out or we can calculate test statistic. We know that because sampling distributions of p1 hat and p2 hat our normal sampling distribution of P1 hat minus P2 hat is also normal provided both the samples are independent, and this is the formula for test statistic. And because we have assumed that P1 minus P2 equal to 0, here we have Z equal to P1 hat minus P2 hat divided by square root of P hat times 1 minus P hat times 1 over N1 plus 1 over N2. We have already obtained these values, sample proportions 0.38 and 0.33, so that we have substituted here 0.38, 0.33. This common parameter is 0.36 and 1 minus 0.36, that is 0.64. Sample size for first sample is 150, for second sample it is 100. So we use scientific calculator and we find that value of test statistic is 0.8061, and if we round off up to 2 decimal places it becomes 0.81. Now once we calculate test statistic, the next step is to decide critical regions. So here our distribution is standard normal, and we know that it is a bell-shaped curve, symmetric curve, and we have right-tailed test. At the center the value of Z is 0, and because we have right-tailed test, we consider area in the right tail, and level of significance is 0.05. Therefore this point is denoted by Z suffix 0.05, and this area is 0.05. So we can use cumulative probability table for normal distribution to decide this value of Z. Now once we know that this area to the right of this point is 0.05, area to the left will be equal to 1 minus 0.05, because total area under this normal curve is always 1. So this area is 0.95, and we know that area under this normal curve is nothing but probability. So this is to the left of this point, therefore we can say that probability that value of capital Z is less than this value of Z is equal to 0.95. Area to the left of this point is this cumulative probability, and that probability is 0.95, and we are interested in this value such that this area is 0.95. So we will go for a normal probability tables. Here just a minute, I have to search for normal probability table. So here I have all the statistical tables. So let me search for cumulative standard normal distribution. So we are interested in the value of Z, which is denoted by Z suffix 0.05, such that area to the left of this point is 0.95. In this table all these values are areas to the left of that particular value of Z, and we are interested in 0.95 area. So here I can see this is 0.9505 and this is also 0.9495. If we round off up to 2 decimal places, then these two are 0.95 up to 2 decimal places. So what we can do is we can take the average of Z values corresponding to these two values. So here the value of Z corresponding to this row is 1.6, here it is 0.04. So for this value of for this area corresponding value of Z is 1.6 plus 0.04, that is 1.64. For this value the value of Z is 1.6 plus 0.05, that is 1.65, and we have to take average of these two, that is nothing but 1.645. This is our Z critical value. So we use this as our critical value. This is this point. This is nothing but 1.645. So let me write here, just a minute. Okay, fine. I have sketched that graph here. You can see here that the value of Z critical value is 1.645. So this value is 1.645. Therefore, area to the right of this value is rejection region, and the calculated value of test statistic is 1.81. So that is to the left side of this critical value, or we are in non-rejection region. So because this value is smaller than this value, we are in non-rejection region. That means we fail to reject null hypothesis. So here I have written, since Z equal to 0.81 is less than 1.645, we fail to reject null hypothesis. And what is null hypothesis? Null hypothesis is that population proportions are equal, that is, number of patients cured by allopathy and homeopathy have same proportion, or proportion of patients cured by allopathy and homeopathy is same. So the conclusion is, there is no reason to believe that allopathy is better than homeopathy at 0.05 level of significance. So in this way we can compare two population proportions. Also, all we have to remember is this formula for test statistic, that P1 hat minus P2 hat divided by square root of, just a minute, P cap times 1 minus P cap into 1 over n1 plus 1 over n2, where this P hat is the given by x1 plus x2 divided by n1 plus n2, and it is the estimator of two equal population proportions. Okay, fine. So I think you are able to understand this question. Here we have compared two treatments. One treatment is allopathic treatment, another treatment is homeopathic treatment, and by taking two samples related to both the treatments, we are able to answer this question. So whenever you have this type of question, you must check that these two assumptions are satisfied. If those assumptions are not given in the question, you must write that with these two assumptions you are answering these questions. If these two assumptions are satisfied, then only we can apply this test statistic for comparing two population proportions. So this is all about this session. I hope you like it. Thanks for watching.